Well, welcome back. Thanks for joining me for part 2 of a Schoology review on Chapter 5. Thanks for tuning in. Let's start with question 7, and this will go through the end of the Schoology review. At least that's my plan as of right now. So let's take a look. Question 7, evaluate 8 raised to the negative 2/3. So we kind of walk you step by step here. Step 1. You would set it equal to 1 over blank, and that would be 8 raised to the 2/3. Type what is in the blank only, meaning don't type the 1. We gave you the 1 right here. And do not use spaces. Okay. So 8 raised to the 2/3. Step 2, you would evaluate that and get what? So if we had, don't forget that it's 1 over that. So 8 to the 2/3, we can rewrite this as 1 over the cubed root of 8 squared. So whatever number is in the denominator here, that is equivalent to the index, or the root that you're taking, the third root of 8. And the third root of 8 is a well-known number, 2 squared. So 1 over 2 squared is 1/4. So we would state the answer as we get 1/4. Next question that's still within question 7. The next question is this one. We'll have to simplify these. So these are properties of exponents. So I'll just remind you, if you had like x squared times x to the 5th, what would you do? Well, you just add, right? 2 plus 5. Same thing here for the numerator. You're going to have 4x, and you're going to do 1/4 plus 1/2 over x to the 7/8. So let's add 1/4 plus 1/2. Let's see, 1/4 plus, we need a denominator of 4, so 1/2 would be 2/4. So that looks like it would be 4x to the 3/4 over x to the 7/2. Now it's pretty tempting to leave the answer like this. However, we are not fully simplified yet. You cannot have rational exponents, exponents that are fractions. You can't have rational exponents in the denominator. So we have to fix that. It's basically similar to the idea of rationalizing the denominator. And to do that, what we can do is we can multiply the top and bottom by x to the something. I'm going to do a little highlighter so you can think about this. X to something, so that when we multiply the denominator x to the 7/8 to x to the something, we would get x to the 1st. So let's think about that. If we had x to the 7/8 times x to something, and we want it to be equal to x to the 1st, so there's no more fraction in the denominator. Well, properties of exponents is that we'd be adding the exponents plus something equals 1. So that something there, it looks like we want 1/8. Can't really see that very well. 1/8. 7/8 plus 1/8 is 1. So we should use a 1/8 here. So when we multiply these, we'll wrap around over here. So we would get 4x to the 3/4 times x to the 1/8 over x. And we're almost there. We just have to add fractions again. You should be getting good at adding fractions. To simplify this and this, we need to do 4x raised to the 3/4 plus 1/8. So we just need 3/4 plus 1/8, which would be, in terms of eighths, would be 6/8. So that would be final answer, 4x to the 7/8 over x. And we're having you type the numerator and the denominator without any spaces. So that was number 7. That one took a little while, but that's all right. Question number 8. Consider the graph of f of x, which is in red. Would be good to note this point, which is 2, 1. Which of the following graphs shows the inverse of f? Well, if it's an inverse, we just need to swap this point. So the graph should have, the answer should have the point 1, 2 on it, 1, 2. So let's look at our options and see if we can just base it off of that answer. Which graph has 1, 2? So let's see, where are those graphs? Here we go. This graph, does it have 1, 2? No, so it's not graph F. This graph, ooh, 1, 2. That's promising, promising. Let's keep looking. This graph, 1, 2, no. And let's see, this graph, oh, we have 2 options. This is promising, not this one. And last one, 1, 2, no. Okay, so we have 2 options. We have the J graph, okay, take a look at that. And we have an option of the G graph. Okay, take a look at that one. So let's check out, do we know any other points on this graph? Well, it looks like we know this point. See if that helps. That point is 3, 2. So the inverse, swapping those, the inverse should have 2, 3 on it. So let's see what graph has 2, 3. Does this graph have 2, 3? Yes, it does actually. Does this graph have 2, 3? Oh, yes, it does. Well, we need another point. So what point do those graphs not have in common? Let's see. What point should we pick? They definitely look different. Hey, wait a second. This graph, is that identical to this graph? The same shape. So if this graph has, let's see, what's another good point to try? How about, maybe we'll pick a weird one and see if that helps. How about this one? That's about 1/2, -3. If we swap those, -3, 1/2. Is that on both graphs? -3, 1/2. So let's see, -3, 1/2. -3, 1/2. No, it's not on G. Let's see if it's on the other one. -3, 1/2. Aha! There it is. The answer is graph J. I wanted to point out initially that this shape is identical to the shape that we started with, but doing a reflection over the y equals x line, you're going to get a different shape. It's not going to be the same, like down and then going up like that. So it actually kind of reflects, and it's backwards looking or upside down, whatever you want to call it. So I knew that J was the way to go, but I wanted to look at individual points, swapping x's and y's, and see if that could help visualize it. Okay, question number 9. Find the inverse of this function, and it's a multiple choice. So to find the inverse, again, we swap x and y, and we're going to replace this f of x with y, because it's a little easier to look at. So we're going to have x equals 3y minus 7 over 2. And then next we solve for y, so we're going to multiply both sides by 2, add 7, and then divide both sides by 3. So we need the answer that looks like 2x plus 7 divided by 3. And g of x is defined as the inverse of f. So you don't have to figure out how to type, or I didn't have to figure out how to type the inverse of f on Schoology. So it looks like that would be our answer. 2 more, the last 2. Rationalize the denominator by multiplying by the conjugate. The conjugate is, looking at the denominator, we switch the sign on the inside there. So it would be 1 plus 3 square root 2. That's what we multiply the top and bottom by 1 plus 3 root 2. And don't forget to distribute everything. So -5 times 1, -5. -5 times that would be -15 root 2. Denominator, you get 1 times 1. 1 times 3 root 2. -3 root 2 times 1. And -3 times -3 is -9 root 4. Root 2 times root 2 is root 4. And notice that the middle term will always equal 0 when multiplying by the conjugate. So to simplify this a little bit, we would have I'll write this down here. 1 minus 4 times 2. Sorry, 1 minus 9 times 2. Square root of 4 is 2. And negative 5 minus 15 root 2. Okay, so that would be, let's see, this denominator here would be 1 minus 18, so negative 17. Negative 5 minus 15 root 2. They're all negative. We don't like negatives in the denominator, so divide by negative and it makes them all positive. So your numerator, you would get 5 plus 15 root 2, and your denominator would be 17. All right, last one, number 11. Typing a cubed root, CBRT, of x will be the cubed root. So we multiply the stuff on the inside, so we're going to have one big cubed root. 4 times 16. 16, since we're looking for 3 of a kind, since it's a cubed root, how about we write 16 as 4 times 4? Now we have a to the 6th, b cubed. So we're going to have a cubed root of 4 cubed. That's going to be a 4. A cubed root of a to the 6th. That would be a squared. 6 divided by 3 is 2. That's squared, 2. And then b cubed is just going to be a b. So there's no more house. There's no more radical. Everything multiplied and simplified out. And we do not need absolute value bars because we have an odd index, so no absolute value bars. So this would be our answer. I know it says remember to consider absolute value bars, and I did consider it, but we don't need absolute value bars here. Ooh, that was a lot. I hope this video was helpful for you. If you have any questions, contact me or your teacher, maybe another teacher, students watching the video. That'd be cool. That'd be cool. I hope you did well. Hope this answers your questions. Please let me know if you have any questions. Good luck on your tests. Bye.